I welcome you for this presentation. In this presentation, we are going to discuss about message authentication. This is the overview of this presentation, that is introduction to message authentication, then message security requirements, then symmetric message encryption, public key message encryption, message authentication code, then message authentication code properties, then requirements for MACs, security of MACs, and summary of this presentation. Generally, the message authentication code, we call it as MAC code. So what is the need for message authentication? So far we have studied many security elements like confidentiality, integrity, then authentication comes into picture. So what is the need for that? In order to protect the integrity of the message, we need message authentication. So here in the message authentication, what we are doing is we are just validating the identity of the originator, from where the message was received, whether we have received from the correct sender or not. Likewise, we have to verify the integrity of the message. Also, we have to avoid the repudiation, that is non-repudiation of origin, that is dispute resolution. Say for example, suppose we receive a message from Alice and Bob receives a message from Alice, but Alice sometimes tell that I didn't send this message likewise. So those type of repudiation we have to avoid. Also, Bob may receive the message, but sometimes Bob will tell that I didn't receive a message from Alice. Sometimes, likewise, some repudiation happens. So in order to overcome that, we need this message authentication. Whether a message is sent from the concerned party to the concerned receiver or not, that we have to verify. Because we have seen some examples like in between the Alice and Bob, Darth is playing the role of both Alice and Bob. So in such situation, we can easily identify if we use message authentication in the communication process, then we can easily identify that some third party is interrupted and we didn't receive the message from the correct sender or receiver. Like that, we can easily find out. So message authentication is for protecting the integrity of the message, that is we are validating the identity of the originator. Then non-repudiation of origin, that is we are resolving some disputes occurring between the sender as well as the receiver using this message authentication. So mainly we are considering the security requirements of this message authentication. So for that we are having three functions. One is the hash function, next one is the message encryption, and third one is the message authentication code. Hash function, you already know, we are giving a variable size input to the hash function and we are getting a fixed size hash value. That hash value is also used to in order to verify the integrity of the message. That already we have seen, and we have studied a famous algorithm, that is Shah secure hash algorithm for the hash function. Then coming to the message encryption, many techniques we have learned for this message encryption. Mainly message encryption provides confidentiality. Next comes the message authentication code. So in this presentation, we will be discussing about what is the use of message authentication code and what is message authentication code we will discuss. So we need and we know some of the message security requirements. This we have studied in the first chapter, that is first unit itself. In the introduction class itself, we have studied these message security requirements. That is, we need disclosure, then traffic analysis, masquerade, content modification, sequence modification, then timing modification, source repudiation, and destination repudiation. So the first two, disclosure and traffic analysis, are coming under the confidentiality part. From the masquerade to the destination repudiation, they are coming under this authentication part. And the last two, source repudiation and destination repudiation, are for the digital signature. So in the authentication part, we have to check this masquerade, then content modification, sequence. These things are for data integrity. So we have to analyze, these are some of the message security requirements, and for authentication we are having masquerade to this destination repudiation. So how to generate the message authentication code, let us see. So in the symmetric encryption process, generally we are telling that encryption provides confidentiality, but in addition to confidentiality, encryption also provides authentication also. The authentication part is hidden in the encryption. How means encryption provides authentication. How it is providing authentication means, and if you are using symmetric encryption, what do you mean by symmetric encryption? We know that in the symmetric encryption we are having is only one key, that is we are having the secret key alone. So both the sender as well as the receiver is using the secret key. So a receiver knows sender must have created it. So before performing the encryption as well as decryption process, we need to share the key. So we know how to share the key using third party or the sender and receiver mutually has to create a key and share. For key exchange only we have seen the Diffie-Hellman key exchange, and also the receiver knows the sender only creates the key, because both the sender as well as the receiver alone knows the key in the symmetric encryption. So the receiver know the sender must have created it, since only sender and receiver now only using the key. So they only know the content that is not altered, because the key is known only to the sender, only known to the sender as well as receiver. So the receiver will think that the message is not altered if the message has suitable structure, redundancy, or a checksum to detect any changes. Because in the receiver side we can have some checksum check or cyclic redundancy check. Many things are there to find out whether any error is present or not in the message. So if you are checking that, and if the receiver is not finding any errors, then the receiver thinks that it is received from the corresponding sender only, because the sender and the receiver only knows the key and the sender only created the key. So here in this situation, the symmetric encryption is providing authentication too, because the sender only created the key and it is shared to the receiver. So from the sender only we are getting the message, because sender alone, they are thinking that no cryptanalysis or brute force attack happens, and no interception occurs. Many things they are thinking that, and symmetric encryption is providing authentication. See in this diagram here, the message is encrypted using the key K. So the encrypted message, that is the ciphertext, is transferred to the or sent to the destination B, and in the destination B the receiver is decrypting with the help of the key K and the message is received. So the B is thinking that everything is received from A, so it is authenticated. Likewise, both confidentiality as well as authentication is provided by the symmetric encryption process. Coming to the public key message encryption, we know that in the public key encryption process, we are having two keys. One is the public key and another one is the private key. So public key can be used for encryption, then private key is used for decryption. The vice versa is also possible. That is, private key is used for encryption as well as public key is used for decryption. So if public key encryption is used, encryption provides no confidence of sender, since anyone potentially knows the public key, because here everyone knows public key is known to all, but private key only the confidential. However, if the sender signs message using their private key, then encrypts the recipient's public key, have both the secrecy as well as authentication. So in this part here, you see here the message is encrypted using the private key of A. Then the encrypted message is passed on to the receiver. Before received by the receiver, it is again encrypted using the public key of B. B's public key, because the private key, A's public key is known to B and B's public key is known to A. So in order to provide confidentiality, authentication and signature, what we are doing is we are performing double encryption process here. First, it is encrypted using the private key of A. How to decrypt that message? It must be decrypted using the public key of A only. So that public key is known to the receiver. So after performing encryption using private key of K, it is again encrypted using public key of B. The encrypted message is again encrypted using the public key of B, because public key of B is known to A. then it is sent to the receiver. So in the receiver side, first the message is decrypted using private key of B, because that private key is known only to B. So using that private key, it is decrypted. Then it is again decrypted using the private key, public key of A, because B knows the public key of A, because that message is encrypted using the private key of A. So it is decrypted using public key of A, then the message is received. So if you are performing double encryption using both parties public key as well as private key, then the public key encryption is also providing authentication as well as digital signature. It is also providing confidentiality too. So this public key message encryption is also used for authentication as well. Next comes the message authentication code, because in order to provide data integrity, we need to have the hash function, then the encryption we have seen, hash function also we know. Next is message authentication code. What is message authentication code? It is this message authentication code MAC. Generally we used to call it as MAC, generated by an algorithm that creates a small fixed size block. That is, this small fixed size block, how we are generating is that depends on both the message and the key. Like encryption, though it need not be reversible. It is a message authentication code is similar to that of encryption, but the encryption process is reversible because we can perform decryption as well. But in this message authentication code, one way only we can traverse, not the reverse part is not possible. That is, from message to message authentication code only we can get. From the message authentication code, we can't get the message. So the reverse is not possible in this message authentication code. That is the difference. So similar to this encryption process only, here we are also performing, we are just modifying the message with the help of the key, but the reverse process is not possible. So here we are appended to the message as a signature. This MAC code we are appending as a signature. So receiver performs same computation on message and checks it matches the MAC code. It provides assurance that message is unaltered and comes from the sender, because it is mainly for authentication purpose. So it is a MAC code is appended using the message as a signature. So that signature is checked by the receiver, and if it is matching, then the sender will receiver will think that it is received, or no modification happen in the message. So here you see the message authentication code is a small fixed size block of data, that is, it is generated from a message from some secret key, that is MAC code equal to C of K comma M. This MAC is appended to a message. See, say for example in this diagram, message is there, then the value of message, some process we are performing. So how we are performing that process, that we can see later. So C of K comma M we are performing, that is the MAC code. That MAC code is appended using the message that is sent to the destination part. And in the destination part, we are having a message as well as the MAC code. So how MAC is generated? It is generated using the message only with the help of the key. So it is again, it is again from the message. Here we are not performing any decryption here. Here from the message, the receiver is generating the MAC. That is the same procedure receiver is applying, that is MAC equal to C of K comma M, because both sides knows the key. The secret key is known by both sender as well as receiver. So using the message, the receiver is also generating a MAC, and the receiver is comparing the generated MAC with the appended MAC in the message. So if both the MAC are same, then the receiver is thinking that it is received from the correct sender. So authentication is maintained. So the difference between encryption process as well as the message authentication code is, here also we are performing some operation with the help of message as well as the key, but decryption part is not possible. In the receiver side also the same procedure is applied, because we are appending the MAC with the message and sending. So the receiver is also generating a similar MAC and comparing that generated MAC with the appended MAC, and if both are same, then the receiver is thinking that it is received from the correct sender. So here we have shown that the MAC provides authentication. It can also use encryption for secrecy, but generally use separate keys for both. In the encryption case, can compute MAC either before or after encryption. That is, if you need to provide confidentiality, in addition to this authentication, if you need confidentiality, then we have to perform this encryption also before or after. So we have to compute the encryption process, perform encryption before generating MAC or after generating MAC, because different combinations are possible. Our ultimate aim is we have to provide security mainly, whether it is authentication case or it is a integrity case or confidentiality case. Main thing is we need to provide security. So we can have some mixed combination, that is before encryption also we can compute the MAC and we can append it, or after encryption also we can do. So why we are using the MAC? That is, sometimes only authentication is needed. So in some cases, confidentiality is not needed, but authentication alone is enough. In such cases, we are just using the MAC, no encryption process we are performing. Sometimes we need authentication to persist longer than the encryption. That is for in order for some archival use and all. Whether some modification happens in that, or it is from the correct person or not. In order to know those things, we need only authentication is enough, no confidentiality is enough, because it is a open access type of thing, but everyone is accessing that document. In such cases, they need whether it is from the authenticated source, that alone is required. In such cases also we are creating a MAC. Note that MAC is not a digital signature. So there is a difference between MAC, message authentication code, and digital signature. It is not a digital signature, it is a separate concept. Some of the MAC properties include a MAC is a cryptosum, that is MAC equal to CK of M. So it is condensing a variable and the message M using a secret key K to find a fixed size authenticator. It is also similar to that of a hash function only. It is a many to one function. Potentially many messages have same MAC. Why it is a many to one function? Because many messages can have a same MAC, so only it is a many to one message, but finding these needs to be very difficult. Suppose we are having a MAC, using the MAC, if you want to find out the message, it is very difficult. Practically it is infeasible. So some of the requirements for MACs include that is, we have to consider the different types of attacks, that is whether it is a cryptanalytic attack or brute force attack. Those attacks are possible in this MAC also, so we have to consider all these for the MAC also. So the MAC has to satisfy the following, that is knowing a message and MAC, it is infeasible to find another message with same MAC. We have already we discussed that it is a many to one function, that is more number of messages may have a single MAC. So suppose we are having a message and the MAC, it is infeasible to find another message with the same MAC. That is one requirement. Then MAC should be uniformly distributed. Then MAC should depend equally on all bits of the message. While discussing about different approaches, these two things we can discuss. Coming to the security of MACs, in block ciphers, we have seen that those block ciphers are vulnerable to brute force attacks as well as cryptanalytic attacks. So this MAC is also vulnerable to brute force attacks as well as cryptanalytic attacks. That is, brute force attacks, it is exploiting strong collision resistance hash having the cast of 2 power m by 2, that is 128-bit hash looks vulnerable, but 160 bits looks better than 128-bit. Then MACs with known message MAC pairs can either attack key space, that is the key search, or MAC. At least 128-bit MAC is needed for security. At least we have a 128-bit MAC. Beyond less bit means it is vulnerable to more attacks. Generally, in the cryptographic techniques, always we have to choose very large numbers. That is, number of bits may be at least 128-bit. Otherwise, if it is less, it is vulnerable to some attacks. Then even brute force attacks. Cryptanalytic attacks may exploit this structure, like block ciphers. They want brute force attacks to be the best alternative for the cryptanalytic attacks. So more variety of MACs are there. It is very harder to generate about the cryptanalysis, generalize the cryptanalysis, because whether we are using the hash function or whether we are using the encryption, whether we are using MAC, anything we can use to provide the security. But always we have to provide security in such a way that the attacker can't extract everything or perform attack everything within that stipulated time. For that only we are giving some large numbers and all. So the attacker will find practically it is infeasible to find or infeasible to provide this brute force attacks using MAC. So we have to design an algorithm in such a way that the attacker may find difficulty in exploiting or getting all the MAC code as well as the message. So we have to design the MAC in such a way. So in this presentation, we have discussed about the introduction to message authentication, then message security requirements. That is the general message security requirements only. And for message authentication, what are the requirements? We have seen that is masquerade, then content modification, then source repudiation, destination repudiation, timing requirements, all those things are there. Then we can provide authentication with the help of symmetric message authentication as well as public key message encryption. Then we have seen what is a message authentication code. It is similar to that of encryption process, but the reverse thing is not possible. That is, decryption is not here. Then we have seen about the MAC properties, then requirements for MAC as well as security of MACs like brute force attacks as well as cryptanalytic attacks. In the next presentation, we will be discussing about some approaches for MAC message authentication code. Thank you.